Let's take a look at a simple problem here. I have a proton. We'll say at x is equal to -2 meters. I have an electron at the origin, or at the 0 of the number line, and then I have another proton here at x is equal to 2 meters. And the question is, what is the force acting on the electron? Now you can think through the answer. I'm going to go through the math because I want to illustrate a point here. So first off, in terms of charge, the charge of a proton is 1.6 times 10 to the -19th coulombs. The charge of an electron is -1.6 times 10 to the -19th coulombs. This shows up so often as sort of a fundamental charge here that this is often just represented by the letter E, and this is be -E. So just please be aware of the difference. This E right here represents that charge, whereas the E with the negative sign represents the electron. There's also another E that shows up in terms of natural logarithms. There's also the E of 2.7182828459045 and so on. That is a different E. We are not involved in this particular time with that. It can show up later depending upon how much math I want to get into at that point. So we are now dealing with this right here. The force between these two is, let's just take a look at the magnitude of the force. The magnitude of the force on the electron from the proton, we'll call this 1. Call that 1, 2, and 3. So this is the force on 2 from 1. Looking at the magnitude, I have 9 times 10 to the 9th coulombs constant, 8.99 if you want to be a little bit more accurate, times 1.6 times 10 to the -19th times -1.6 times 10 to the -19th. Some of you might have noticed an issue already, but I'm going to keep going, times for 2 squared. And I get 5.76 times 10 to the -29th newtons, and the minus sign right there. If I did the force on 2 from 3, well, basically it's the same numbers, so I get -5.76 times 10 to the -29th newtons, and so therefore the total force acting on 2 is the force on 2 from 1 plus the force on 2 from 3. This is why the 2 comes first in terms of this is the receiver of the force and the second number is the source. A mistake is then to add these two numbers straight up and to get -1.152 times 10 to the -28th. The answer is 0 newtons. Now, in another video, and this might be the first one you're seeing where I make a mention of this, when you're dealing with direction, you can either think through it in advance or place strict adherence to the math. So let's first do the think through. I know that these are attracted, so this is the force on 2 from 1. I know these are attracted, so this is the force on 2 from 3. Since the magnitudes really should not have the negative sign in here, that really should be positives. But do I still add them together? I should still get 0 because they're in the opposite direction. I have an object here. I have a force of 5.76 units going to the right, and I have a force of 5.76 units going to the left. They cancel each other out. Now, how would I do this plain strict adherence to the math? Well, if I can actually get to the next page, I can show you. All right, so the force on 2 is the force on 2 from 1 plus the force on 2 from 3. The force on 2 from 1, we do K, and sometimes I'll put a little E down here for the electrostatic constant. Sometimes I'll put a C for Coulomb's constant, and sometimes I just leave it blank because I'm feeling lazy. Times charge of 2 times charge of 1 over the distance between 1 and 2, then R, this is the force on 2 from 1, R1 hat, plus K sub E Q2 Q3 over R23 R3 hat. You work through the math here, you end up with -5.76 times 10 to the -29th R1 hat plus -5.76 times 10 to the -29th I guess that would be newtons, newtons r3 hat. These are not in the same coordinate system here. If we're playing strict adherence to the math, you have to keep track of what your reference is. These are not in the same coordinate system. We need them in the same coordinate system. If I go back to my original drawing here, I'm just going to rewrite that over here. I have at x equals 0 an electron. I have a proton over here at x equal to 2 meters and at x equal to negative 2 meters. This is 1, 2, and 3. R1 hat is going away from this proton 1. In other words, at this point, R1 hat is traveling to the right. R3 hat, R sub 3 hat is going away from this right here. So at where the electron is, R3 hat is going to the left. They are opposite directions. So we need to recognize that at the location of the electron, R1 hat is equal to negative R3 hat at x equal to 0 meters. So now we can make that substitution since this is at that location right there. We can stick in a negative R3 hat in for this. The negatives will cancel out, and I'm left with positive 5.76 times 10 to the negative 29th newtons R3 hat plus negative 5.76 times 10 to the negative 29th newtons R3 hat. And that is 0 because I got a number and then the negative of it that I'm adding together. Or you think through it. And so please keep that in mind. That is something that we will do throughout. Oftentimes we will think through it because it's a whole lot easier than going through the math and making sure you're in the same coordinate system.